Hello, geometry students. Here's your lesson for section 1-3, measuring and constructing angles. Missy McCarthy, Okemos High School math instructor. By the end of this lesson, hopefully you will say, I can name angles in various ways, classify angles as acute, right, obtuse, and straight, use a protractor to find the measure of an angle, recite and use the angle addition postulate and to find the measure of angles, and correctly use the term congruent and the arc marks to identify congruent angles, and use angle bisectors to find angle measures. So our definition of an angle, we can define an angle based on some of the other terms that we have previously defined, and an angle is defined as a figure formed by two rays or sides with a common endpoint. That common endpoint is going to be called the vertex of the angle. There's several ways that you can name an angle. So you see our angle here is made up of two rays. It's made up of ray RS and made up of ray RT that meet at a common endpoint called our vertex. So R is our vertex. The interior of the angle is all of the space between the two sides, and then the exterior of the angle is everything on the outside. Okay, so the three ways you can name the angle are the following. Oops. Let's do this. One, you can name it angle R simply just by the vertex of the angle. You can also name it using the 2 points on the sides, S and T. So you can name it angle SRT with the vertex being in the middle, or angle TRS with the vertex also still being in the middle. Or sometimes they put a little number on the inside of the angle and the interior, or you can call it angle 1. So there are the four ways that you can name an angle. When we measure angles, it's actually based on a circle, and the fact that a circle all the way around is 360 degrees. So you start at 0 degrees here, you rotate all the way around. By the time you get back to the beginning, you have rotated a total of 360 degrees. For the most part, the angles in this class are all going to be less than 360 degrees. So we're going to be starting at one point, and we're going to be rotating around to here, what we call or that's going to form opposite rays actually. So if you think about one side of the angle being there and the other side of the angle being there, so let's put a T in the middle, let's put an S here and an R here. So we've got ray TS and we have ray TR, and they are opposite rays because they form a straight line. We're looking at only half of the circle, so that would be 180 degrees if we start with 0 degrees over here. So all of our angles are going to be anywhere between 0 and 180 degrees. Now we have a tool. If I keep drawing here, it has little tick marks on it, 180 little tick marks, okay, representing our degrees, and this is what we call a protractor, and that's what we're going to use. That's our tool for measuring angles. All right, so if we look here at a protractor, we have a couple angles that we are going to try to measure. The first angle we're going to try to measure is angle WXV. So WXV. It's important that we name this angle using 3 letters because there are several angles that have a vertex at X. So if we just say angle X, nobody will know what you're talking about. But if you say angle WXV, people know exactly what you're talking about. So if we look at measuring this angle here, we'll see that the first side is in line with 0 degrees. So that's very important that one side of your angle is in line with 0 degrees if you want to just measure an angle in this way. And then we rotate all the way up until the other side of the angle right here is in line with, now it looks like 30 degrees or 150 degrees because there's 2 numbers on here. But we know that 180 degrees makes our opposite rays, and we didn't quite go 150, we only went about 30. So that is going to be a 30-degree angle. So what we would write is the measure of angle WXV equals 30 degrees. You need that little M there saying that you have found the measure of the angle. All right, so let's get rid of these markings here and see if we can find the next angle. Okay, here we go. Angle ZXW. So now that's the angle that we're looking for. So if we want to find the measure of that angle, we seem to be in a little bit of trouble because none of the sides line up with 0. But if I look here, this side I know is 30 degrees, and we're going all the way from 30 degrees all the way around to not 50 degrees, all the way to 130 degrees. Okay, so from 30, if we keep going up, following those numbers on the bottom, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. So if we start at 30 and we go to 130, we find that the measure of that angle is actually 100 degrees. So we would say the measure of angle ZXW equals 100 degrees. All right, we have several types of angles, which you guys are very, very used to using these terms, I know. If you have an angle that's somewhere between 0 and 90 degrees, we are going to call that an acute angle. If you have an angle that measures exactly 90 degrees, we call that a right angle, and we indicate that it is exactly 90 degrees by putting a red square in the corner. Exactly 90 degrees, a right angle. I remember teaching my daughter that last year, and she was very confused. She kept asking me where the left angles were. Our angles that are between 90 and 180 degrees, we're calling an obtuse angle. And lastly, whenever an angle is formed by two opposite rays, we rotate it all the way around 180 degrees. We are calling that a straight angle. So a postulate that we're going to be using in this section primarily is called the angle addition postulate. And it centers around the fact that if you have two angles right next to each other and they share a side, so you have this point S that's on the interior of the angle, so you can draw ray QS on the interior of the angle so that the two angles share a side. When you add the two smaller angles together, they equal the bigger angle. So if you see here, we have angle RQS, or angle SQR, and if we add that to angle PQS, so the blue angle plus the red angle, we get the big angle. We get angle PQR. So that is the angle addition postulate. And for short, you might see me write angle addition postulate instead of writing the whole thing out. So how would you use the angle addition postulate? Well, let's look at this angle here. You'll see we have F on the interior of angle DEG. So they tell us the measure of some of our angles. We know that one of them is 115, the other one is 48, and they want us to find the third angle. But first, I'm going to use the angle addition postulate just to write some things out here. So the first thing I'm going to do is say the measure of angle DEF plus the measure of angle GEF has to equal, so that's DEF and GEF, have to equal the measure of the whole thing, angle DEG. So now I'm going to substitute in what I know. Do I know DEF? I do. I know that DEF is 48 degrees. So 48 plus the measure of angle GEF, or that could also be called FEG. Do I know that? No, that's what they want us to find. So I'm going to call that X. And then the measure of angle DEG, I know that. That is 115. So now I can find my missing angle. If I subtract 48 from both sides, so 15 minus 8, that's 7. I think we get 67 degrees. Okay? So the measure of angle FE, that should be an E, FEG is 67 degrees. So we found the missing angle, and that was using the angle addition postulate. Just like we had the concept of congruent segments, we also have the concept of congruent angles. But instead of using tick marks, in order to highlight congruent angles, we use these arc marks. So you see this one red arc mark here on angle ABC, another red arc mark here. Let's call this angle DEF. That means those two angles are congruent. So I would say the measure of angle, there's two ways I can write this. I would say angle ABC is congruent to angle DEF, Or I would say the measure of angle ABC is equal to the measure of angle DEF. Again, I want to say angles are congruent. The measures of angles are equal. Objects are congruent. The measure of the objects are equal. So here, because we have this green here and this green here, we would say that angle LJK is congruent to angle MJK, or the measure of angle LJK is equal to the measure of angle MJK. Now, we have a special term for this whenever a ray divides an angle into two congruent angles. That's called an angle bisector. So here we're going to talk about an angle bisector is a ray that divides an angle into two congruent angles. So if I were told, for example, oops, make sure I grab the pen here, that JK bisects angle LJM. First, I'm going to draw angle LJM. LJM. Got my angle. Now, JK is a ray, and it bisects. JK is a ray that bisects angle LJM, which means it divides it into two congruent angles. So I can put tick marks on here, one tick mark or two tick marks here, congruent to that one. If I put 3 tick marks here, I need to put 3 tick marks here to say that those angles are congruent. So angle LJK is congruent to angle KJM. And that's what we call an angle bisector. An angle bisector is a ray that divides an angle into two congruent angles. All right, so let's use this idea of an angle bisector in order to find the measure of angles. So I know that KM bisects JKL. As soon as I see that, I'm going to draw a picture. My main angle is JKL. JKL. KM is the angle bisector. And I'm going to indicate it's the bisector by putting some tick marks on there. So I'm going to put 3 tick marks this time. Those 3 and those 3, saying that those two angles are congruent. Now they give us some more information. They tell us that JKM is 4x plus 8. JKM, this angle right here, is 4x plus, I'm sorry, I said 8, should have said 6. Then they tell us that MKL is 7x minus 12. 7x minus 12. They want us to find the measure of angle JKM. JKM. So if it's an angle bisector, that means it divides the angle into two congruent angles. So that means that these two measures are equal. So I can say that 4x plus 6 has to be equal to 7x minus 12. If I subtract 4x from both sides, I get 6 is equal to 3x minus 12. If I add 12 to both sides, I get 18 is equal to 3x. Divide both sides by 3, and I get x is equal to 6. Now remember, I want to find the measure of angle JKM. So JKM is this guy right here. So I'm going to take 6 and I'm going to plug it back in. The measure of angle JKM is equal to 4 times 6 plus 6, which is 24 plus 6. And so the measure of that angle is 30 degrees. So let's finish wrapping up with your I can statements. I can do the following now. I can name angles in various ways, classify angles as acute, right, obtuse, and straight, use a protractor to find the measure of angles, recite and use the angle addition postulate to find the measure of angles, correctly use the term congruent and arc marks to identify congruent angles, and use angle bisectors to find angle measures. Hopefully you're proficient, or at least ready to try to become proficient in all of those I can statements. See you in class.